Alright guys, to start the lesson today we have a warm-up. There are 3 problems. I want you to take 3 to 4 minutes to do as much of this as you can. And if you're not sure how to answer one of them, that's okay. Skip to one that you feel more confident on. But take 3 to 4 minutes right now. Try numbers 1, 2, or 3. And then we'll play the video and I'll talk through my thoughts on numbers 1, 2, and 3. Pause the video now and do the warm-up. Alright, when I look at this equation, when I'm thinking through number 1, it says, what are 3 things you know about the graph of this equation? Well, first of all, it's y equals a constant and then minus 3 times x. And I could rewrite that as y equals negative 3x plus 6. That's a positive 6. And this looks like that y equals mx plus b, or the slope-intercept form that we were talking about yesterday or earlier in the unit. So right off the bat, one thing I know is that this is a linear function. So the graph is a line. I'm also looking at this, and I remember that when we had the plus 6 at the end, that translated the function up 6 from the parent function. So that plus 6 means that the graph, or the entire function, is translated up 6 from the parent function. Which what that ends up meaning is my y-intercept ends up being 0, 6. I also see this negative out front, and that negative tells me that the function is decreasing because this guy tells me about my slope. And so the function, or the line, is decreasing because the slope is negative. Now those are 3 things, but I'm also noticing a couple other things. I know that that 3, when I multiply by a 3, it's going to make it steeper than the parent function. So the graph, the line, will be steeper than the parent function y equals x. And I could just use these 2 things together to say that the slope is negative 3 because that is the coefficient of x. And this tells me more about what does a slope of negative 3 really mean. All right, the next one says, how many points do you need in order to graph a line? All right, so I'm thinking about this. Is it 1, 2, 3, 5? I know that there's infinitely many points on a line, but how many do I actually need in order to graph the line? So I'm thinking about that. If I was looking at a coordinate plane over here, if all I had was 1 point, that wouldn't be enough because I could draw a line a whole bunch of different ways through that 1 point. Okay, if I have 3 points on the line, well, that's definitely enough. I can see the line's going to go like that. But the question is, do I really need all 3? And what I look at and what I can reason through is as long as I have 2 points, I have somewhere where I can start and I can get another point. From there, I can find my constant rate of change. So I could go up and to the right, and continue that, or down and to the left and continue that, and I can find the rest of my points. So how many points do I need to graph a line? I need 2, because from those 2, I can plot the rest of the points on that line. So I want to use our answers from numbers 1 and 2 and that knowledge to talk about how we could do 3. It says graph this line without making a table first. We've been creating graphs by substituting inputs for x and finding the outputs and plotting points, but we don't need to do that. So when I look at this, I can understand, well, if I need 2 points, 1 point I for sure know is this y-intercept right here. I remember that if I subtract 4, I translate down 4 from the parent function. So the first point that I know I will have is a y-intercept of 0, negative 4. So my first step, if I'm going to graph that without making a table, is to plot the y-intercept, because that is a point I can identify right away in that equation. But then I need another point in order to be able to plot the rest of them. So I look at this and I see that this equation has 3 over 2 as a coefficient of x, which means 3 over 2 is my slope. So my next step is going to be to use the slope to plot another point. And in fact, I can plot many more points, so or multiple points. So if that's my slope, 3 over 2, remember that slope is our rise over our run. So I'm going to rise 1, 2, 3 and run 2. The question is, should I go to the right 2 or to the left 2? And I know that that slope is positive, which means I will have an increasing function. So from here I need to increase. So I know that this is in fact the right point. So then rise 3, run 2, rise 3, run 2. And now I've plotted 4 points or 4 solutions of the line, but we know that a line has infinitely many solutions or infinitely many points. And so I'm going to draw this line connecting all of them to show that we continue on. And that's how we graph the line. So I want you to use what I'm talking about here in order to practice graphing lines without having to make a table, just by looking at the equation. So what we're going to do is I'm going to give you guys a problem. You guys are going to try and graph it on your own with your partner, and then I'm going to show you the answer and you can check it. And then you can switch partners, do rock, paper, scissors. We'll do a new partner and do number 2. So number 1, your equation, let me zoom in for you a little bit here. Your equation for number 1 is y equals 1/4 x minus 1. I want you to spend 1 minute with your partner, graph number 1. Go. Pause the video and go do that right now. All right, so now that you've tried this on your own, I'm going to talk through my thought process. I'm looking at this and I recognize that I have 1/4 as my coefficient of x, and I'm subtracting 1. That minus 1 means I translated down 1 unit from the parent function, so that is my y-intercept. So minus 1 is my y-intercept. That 1/4 tells me the steepness, my slope. So I rise 1, run 4. I rise 1 and run 4, or I could go down 1 and left 4. And when I draw my line is rising from left to right, which is good. We're increasing because my slope is positive. And now I look at this, I see the number in front of x is less than 1, and so it is less steep than the parent function. That makes sense, and we were translated down 1, so that also makes sense. All right, your next equation is going to be y equals a negative x plus 2. Go ahead and try graphing this on your own and pause the video, and after 1 minute, we'll play the video again, and you can check your answer. Go. All right, so when I look at this equation, I don't see a number here, but that is an imaginary 1 times that. So when I'm multiplying something and I don't see the number, it's a 1. So in order to plot a point, I have to first plot the y-intercept. That plus 2 means I translate up 2 from the parent function, or I have a y-intercept of 0, 2. That negative 1 means I'm going to be decreasing because it's negative, and I can put this 1 over 1 if I want to say I rise a negative 1 and I run 1. So I'm going to go down 1, right 1, down 1, right 1, and I can continue that pattern. And I see that I do have a decreasing function when I do that, which is good because my slope is negative, or up 1 and to the left. And I connect my points, and I'm good to go. All right, number 3 is going to be y equals negative 4 plus 4/3 x. Go ahead and graph this one with your partner and pause the video. Now that you've tried this, let's talk through it. Now this one's written in a different order, that the x is coming at the end. If you want to rewrite it, you can. That's the same thing as saying y equals 4/3 x minus 4. In which case I see that my y-intercept is a negative 4. I mean, as I've translated down 4 units from the parent function, I use my slope of 4/3, rise 4 and run 3, rise 4 and run 3. And when I graph this, I see that my line is increasing, which is good because my slope is positive. All right, let's turn to the back. And you are working on number 4 now. The equation for number 4 is y equals 5. Try and graph y equals 5 with your partner and pause the video. Now that you've tried it with your partner, let's talk through this. This one looks different. I don't see an x anywhere. So the question is, where's x? Well, if I don't see an x, I'm thinking, what is the coefficient of x? That means I have 0 x's plus 5. So my slope is 0 this time, but I'm still translating up 5. So I go 1, 2, 3, 4, 5 is my y-intercept. And a slope of 0 means I'm not increasing or decreasing. I'm remaining constant. I have that horizontal line. So I have y equals 5, looks like that. All right, number 5, your new equation is f of x is equal to 2 minus 3x. Go ahead and graph this one with your partner and pause the video. Now that you've tried this on your own, let's take a look at this one. This one's another one where it's kind of mixed around. If you wanted to rewrite it, you can. Make sure that negative stays with the 3. That's a negative 3x, and that's a positive 2. So I look at this, a plus 2 translates up 2 from the parent function, or a y-intercept of 0, 2. The negative 3 will have a slope that is negative, so we're decreasing. I can put that over 1 so I can see my rise and run. So I go down 3, right 1, down 3, right 1, or I could go up 3 and to the left and still get that decreasing line, which is what I want. Draw my line, and I am good to go. Let's get you over for number 6. Number 6 is going to be g of x is equal to 3/5 x. Go ahead and try this with your partner and pause the video. Now that you've tried this one on your own, I want to think through, what will I do if I don't see a plus or minus something? Well, if I'm not adding or subtracting anything, or it's not written there, what's implied is an imaginary plus 0. So there's a plus 0, which means I'm not translated up or down at all. I'm at the same starting point as the parent function. So I have a y-intercept of 0, 0, or in other words, I'm not translated up or down, but I do have a slope of 3/5. Which means I rise 3 and run 5, or go down 3 and left 5. So I can plot that point. Again, I double check. I'm increasing, my slope is positive, that's what I want. So I can graph this line, and I'm good to go. All right, my next equation, number 7, is going to be negative 4x plus y equals 3. Go ahead and, with your partner, try and graph this equation and pause the video. Now that you've tried this, I want to